Hello! Welcome to this Big Clive style teardown video of this Panasonic eX2 in-flight entertainment monitor. This particular monitor has come from a Boeing 747, once flown by Virgin Atlantic. The tail number was G-VXLG, which is an airplane originally registered in 1998. I'm going to guess that this has been retrofitted at a later date by the airline, as the eX2 didn't actually come out until about 2006. I apologise for the desk. I actually have a desk on top of a desk, and that's because I'm currently programming a light show for a friend's wedding, and I don't really want to move it because it's incredibly heavy and cumbersome to do so. So, I have actually got two of these screens, one of which I have already disassembled. You'll notice the back of them look different. That's because this one is from the front aisle seat, which has one of those fixed monitors that swivels down to the side of you with a little pop-up table, whereas this is an actual seat back model. The internals, I believe, are all the same. It's just the rear casing for this obviously is a little bit more passenger or consumer facing, whereas this is tucked away, never to be seen by anyone apart from the technicians. So I've got two of these screens because I have purchased a seat from that very aeroplane, which has been turned into an office chair. And I've done so because I really just want to try and bring the screens back to life in a meaningful way. And for me, that means switching out the screens for something a little bit brighter and newer, but also to try and get something that I can actually get a computer into, or what I think I'm probably going to do is just try and retrofit a tablet into there, because it's surprisingly about the right size. Now, the screws are quite deeply recessed in, so you do need sort of a fairly long screwdriver or something like this to do. And you can probably start to see already, there's an incredible amount of dust. When I did the first one, I was quite shocked at how much dust came out. It was borderline sort of fire hazardy as to how much dust had come out, but you're going to experience that with me as we tear this one down and just see what I mean. With all these screws out, they're just normal Phillips screws. I'm going to pull the back off and it opens like this. Once we've taken the back off, the next thing we have is this sort of protective shield. Again, all Phillips screws, so I'm going to go ahead and take those off now. Before I take the back cover off, I just want to talk about some of the screws. So anytime that they have something structural which they've had to secure together, they have used a normal washer, but they've also used a split ring washer over here. These sort of compress when you screw them in, and they do a fantastic job at stopping the screw from actually moving, even under quite extreme vibrations. So a good design principle there for something that obviously goes through quite a lot of vibrations every single day. And as I take the back off, you shall see it is an absolutely dusty, disgusting mess. One moment please, as I now go and hoover this out and come back with hopefully a slightly cleaner board. Right, I'm back. Thank you very much for bearing with me. I've gone and dusted as much of it as I can. Interestingly, the seat back model, that's the one from the back of the seat, is in slightly worse condition. There's quite a bit of almost liquid ingress and damage compared to the side of the seat one, which I originally pulled out here. So the two boards appear to be identical in terms of componentry. The only difference being the connector is on this sort of extension or 90-degree angle daughter board, which just plugs in to the port down here. Taking a look at this board before we dive into some of the components, you'll see another technique they've used, because this has obviously come out of an aeroplane, called component staking. You'll have seen the traditional type of component staking on quite a lot of consumer boards as well, which is essentially sort of just dabs of glue or adhesive to stop bits from moving about or coming off. But this board, being aircraft grade, has obviously gone one step further, which is they've component staked pretty much everything, even directly at PCB level. I'm not sure how much of this shows up on camera, but you'll see there is almost this sort of yellow goo all over it. And that's a type of UV cured bond that you typically use when you really want to stake properly. And so you'll validate the board normally, and then once you're happy with it, you'll pour it onto the areas that you want, apply a bit of UV light, and then it hardens. It does make it pretty much impossible to repair a single IC or component. At that point, you're normally looking at board swaps, but it's very interesting that they've gone and done it. We'll take a look at the other side as well, which is quite crazy, because here pretty much everything has been staked, even in different areas where they've obviously just poured it and let it run around. But that is a little look at the component staking that they've done. So let's jump into what we can see on the board. Starting with, I guess, what it looks like from the side there. It's a relatively slim board, but as you've probably already figured out from some of the components that you can see, this is an embedded computer. We've got a compact flash drive here, which is likely for holding the operating system. Compact flash is a very popular way of holding your operating system as something that you can boot off. Also makes it somewhat easy to swap it out in the case of major upgrades and you can't flash it. We've got what appears to be standard laptop size SODIMMs. Given the age of this is probably going to be DDR1, maybe DDR2 at a push. I can't imagine it used very much memory, probably less than half a gig if I'm honest, maybe 256 megs. We've got the fan underneath here, appears to be some kind of CPU. I'm going to guess it's some kind of BGA attached to CPU of some sort with the little fan header going there. We've got our main connector that we saw earlier, which is the single sort of D-type connector for the rest of the aircraft, which provides power as well as communications back to the central server that this would have talked to. And then we've got here what appears to be our backlight inverter board for the monitor, or the display rather, that we'll go into slightly later, which is sat on top of the actual main board. Looking at the underside of it, it's quite interesting. Everything else is quite pretty, but this LVDS cable, which drives the monitor, rather than a traditional ribbon type cable, appears to be just the plain strands of it. But there we go, and that's what the underside looks like. So, as we go back to our seat back unit here, we're going to continue tearing it down just so you can see all the different layers. With all the screws out, before I pry this off, I'm just going to disconnect the connectors that are sticking bits together. So the first one we're going to disconnect is up here, and this is the digitizer ribbon cable. So if I just slide that up, the digitizer bit comes out there. I'm going to leave the backlight inverter board, daughter board connected because it won't really cause any problems leaving that connected. The more delicate one I am going to disconnect, so this is presumably powering the backlight for the actual monitor, which bundles into that LVDS connector that we saw. Next is the 10 pins for the buttons on the front, which are these little clicky buttons here. In a future project I will be tapping into these and connecting these to a ESP32 to make the buttons continue to do something for me on my future project. This is the connector for the fan header. I'm going to leave that in place because it's part of the board and I don't mind. The last thing we're going to take off, which is the rather delicate one. Eagle-eyed viewers may have noticed that I accidentally ripped it off on my original board, which is aptly marked the credit card, and that's because there is a credit card reader down here, presumably for in-flight calls and possibly a bit of gambling, as that was an option back in the days. Right, everything's out, but I have lied, unfortunately. I do need to take out this one screw on the backlight inverter board, which comes off here. And this reveals one of my favourite things. There were actually a few more of these on the seat variant, but these standoffs here are not only used to raise additional boards like our connector board and in this case our backlight board, but they also work as an additional screw. And this happens to be the final screw that's securing this board into the back of the monitor itself. As I flip it over, you're just going to be a little bit careful because you'll notice that the video side of the LVDS connector is still there. So next thing is just to pry this out. And with that out, we have once again our board freed and ready to go. After that, it is essentially the digitizer and LCD layer. So once again, what we can see here, another little shield there, which has got all of our heat sinks. So it appears to be using this shield as a bit of a heat sink or just somewhere to dissipate the heats, which line up to where these chips are over here and some components down here, it looks like. Next, we want to get rid of this shield layer here so we can have a look at what's underneath. Which is these two screws over here. Really interestingly, a good, 80% of this disassembly all seems to be done using these same screws. So next is to free the lines of the LVDS connector that were previously taped into place. And then you should just be able to lift this next back shield off. There we go. And now we can start to get a little look at the digitizer and the screen. Behind this insulating layer, we can just about make out that this is a LCD made by NEC. At this point, there are no more screws to take it out. You simply lift up the whole thing and it comes out like this. Got this rather old and quite disgusting digitizer layer there. I'm going to guess that it is resistive given the age. There is also about almost half a centimetre's play on this old resistive style touchscreen, and it is quite literally another layer there. So as I pull them apart here, you can see the final two layers, which is our LCD screen itself, and we've also got our touchscreen layer here. This also appears to be the polarizer, because as I move it about, you can see there that it is obviously polarizing. In case you're interested in the parts number, that is the model number. It appears to be an 8.9 inch screen, and your typical sort of integrated monitor or laptop style. So then, what next for this? What next for this board and why? In an ideal world, I would have liked to have figured out the pinout for this, figured out how to inject presumably 29 volts into this to try and get it to boot. Failing that, I would have liked to dump what's on here and upload it to the internet so someone else can try and get it to boot in a VM. Unfortunately, aside from not having the time to do that, I'm not the best person to do that. I don't have a large enough following, nor do I have the skill right now to be able to figure that out. If you are a fellow YouTuber who knows how to get this to boot, I will send you the board, the digitizer, and the screen, and I would love to see it come back to life. I'm very confident that once you figured the pin out, it should just boot from its own system without the server. The reason being is, having glanced at the eX2 service manual, there's clearly what they describe as a fallback mode, where these are able to operate in a local manner without the central in-flight entertainment server. The other reason I'm very confident this has some kind of video decoding built in is because these in-flight entertainment screens were from a very strange era of video input options that you had next to your seat. You can see here on my seat, I've actually got an S-Video style DIN connector input. It's not S-Video, but it's for connecting your iPod so that you can play music and video straight into the screen. Above it, you can see the composite inputs, where you can play video out of a camera or a laptop if you had a laptop with a composite video output at the time. So that's as far as I'm going to go in this video. I will hold these two boards with their matching screens and digitizers. So if you think you can get it to boot, please let me know, because nothing would make me more happy than to see these do something.